Electromag right-hand rule type practice questions here. Very visual, not mathy, and I've got them kind of pre-filled in. So the idea of the magnetic fields around these two conductors, the external field would be upwards on both of them because north to south orientation. But since the current's coming out of the page for this one, you could use your right hand if you like. The external magnetic field is up. The current's coming out of the page. That wire gets pushed to the left. Conversely, current going into the page, use your right hand again, force is going to be to the right. A single wire traveling in the direction of this I vector here, that's our current, is going to be going this way. Magnetic field orienting from left to right, force is going to be upwards. Again, grab your right hand to plan this one out. Question number 2, honestly, this is a rehash of a portion of the note, but you got to be able to think it out for yourself, and hopefully you did it without peeking at the note. But we'd have a magnetic field around current carrying wire 1, we'd have a magnetic field around wire 2, and then the magnetic field of 1 would be upwards at the location of wire 2. And again, you can use your right hand to say that the magnetic field is up and the current is going into the page. And I know you can't see my thumb very well, but that would mean that my palm is pointing towards the right, which means this guy's going to get forced to the right. Same vein of thinking is going to get you this guy being forced to the left, okay? And then with the same thought process again, two current carrying wires going towards us, we would get to the point where these two wires are being attracted to one another, okay? Again, magnetic field around wire 1 is going to wrap, according to the first right-hand rule, Orsted's discovery, is going to wrap like this, which means its magnetic field is going to be going up on the right-hand side through current carrying wire 2, current coming out of the page, magnetic field in the presence of wire 2 is going to be going upwards, and so it's going to get pushed to the right. Okay? Repulsion, attraction. All good? And then we go on to the next one. It says that a student designs a successful demonstrator for a motor principle, but notices that the force on the conductor are very weak. 2 changes that we could make to make them stronger. We could just jack up the current. Another thing that we could do is wind more wires. And so, yeah, if those are 2 of the factors that would make an electromagnet stronger. So another thing that we might do is just make the wires longer. So have more wire. And you'll see actually all 3 of these things happen inside of a speaker. So inside of a speaker head, you'd have lots of wire, there'd be lots of windings, and you use an amp to give lots of current, right? Number 4, this is actually supposed to be a 2-dimensional schematic diagram of this more 3D diagram over here. They're not the same exact setup, but this setup is meant to be representational of this kind of an apparatus, okay? So again, we have magnetic field external to the wires, orienting from north to south, currents going towards us for the left wire, away from us for the right wire. And so we're not thinking in this case about the magnetic field of the 2 wires mutually attracting each other. We're thinking of the dominant magnetic field as coming from that bar magnet external to the system, or sort of like on the fringes of the system. We're saying that this wire on the left is going to get pushed upwards, while this wire is going to get pushed downwards. And again, this is due to right-hand rule interactions for the motor principle, and that's going to cause CW spin. What do you think CW stands for? Clockwise, yeah? See? I know it says so in the paragraph above, but not everybody reads like a reader does, right? So do like Johnny Do does. Isn't that a kid's book? Don't do like Donnie Don't doesn't. I don't know. I feel like I read that at some point. All right, so we want to make sure that we recognize that CW means clockwise. I wish that there was another one that was going CCW, but this other one's also going CW. And the way that I would map that out is to look at the power source and say, okay, well, the current's coming from the positive terminal. I would literally treat it like a labyrinth. I would follow the path, right? I would say, okay, the current's going to go into the page, and I might even draw an X there to engage my 3-dimensional mind a little bit. And then it would wrap around, come back towards me on this side of the loop. Again, I'm just following the labyrinth. But once I've got that X and dot mapped out, kind of like the 2-dimensional schematic before, now I'm prepared to use my right-hand rule. Remember that this north is going to send a magnetic field this way through those wires over to the south. That means that when I do my right-hand rule, I'm talking about a thumb coming towards me, a magnetic field going this way, and that wire on the right-hand side getting pushed down. And for the same reason, or pattern of thinking, the wire on the left is going to get pushed up. Okay, and so that's going to cause clockwise twisting. Now, if you're not quite sure what clockwise and counterclockwise is, I'm sorry, this is about an analog clock, and the fact that clockwise is for hands that tick this way around a clock face for an analog clock. Okay, so if you don't know which way a second hand goes on an analog clock, that's going to be a whole nother issue. And clockwise and counterclockwise rotations is something that people are probably going to talk about for some time to come, despite the fact that we all seem to have digital clocks these days. Okay, so it is an issue of rotational direction, and we don't seem to have another tool under our belts for talking about direction of rotation. Clockwise and counterclockwise is the way we talk about these things. What are two possible ways that you could reverse the rotational direction of the discussed question in number 5? Well, couldn't I just change which terminal is positive and which is negative? That's a way to do things, 100%. Or I could switch which side is north and which side is south. Equally good. Okay.